I am Vishal Pawar, working as an assistant professor in Department of Chemistry PG. Today we are going to see one topic from the subject CHO 352 Stereochemistry and Asymmetric Synthesis of Organic Compounds of class MSc 2nd Organic Chemistry semester 3rd. The name of topic is Cis-Elimination or Paralytic elimination. We know that in elimination there is a formation of alkene, and there are two types of elimination reaction. Particularly, one is the E2 elimination and another is the cis elimination or paralytic elimination. Paralytic elimination means action of heat. In case of E2 elimination, the steric requirement is that the atoms or groups to be eliminated, they must be trans-diaxial with respect to each other. Then only then E2 elimination or biomolecular elimination is possible. But opposite to the E2 elimination, cis elimination is there, in which if you consider the cis elimination usually takes place by pyrolysis. Pyrolysis means action of heat. The term pyrolytic elimination literally means an elimination reaction occurring in the organic substrate due to the application of heat. That's what is called as a pyrolysis. The pyrolysis of esters like acetate ester, methyl xanthate ester takes place by cis elimination, leading to the formation of olefins. The product in case of pyrolytic elimination is olefin. If we consider some example like acetate ester, methyl xanthate ester, which takes place by the cis elimination. Consider this one xanthate group R O C double bond S S R prime. This is xanthate group, and another one is the acetate group CH3 C double bond O O R. We are going to see the pyrolysis of xanthate and acetate in detail in next slide. They go via cyclic transition state formation like this one. In this case, the reaction particularly go via the six-member cyclic transition state, and there is a formation of olefin as the main product plus the acid as this byproduct. If you consider the reaction of acetate, a general mechanism of elimination is like this one. In this case, if you consider the xanthate group S Me C double bond S O, when it undergoes the pyrolysis elimination, the reaction goes through the formation of such type of six-member cyclic transition state, in which there is a new bond formed between the carbon-carbon atom, as well as there is a double bond formation between carbon-oxygen atom, and the double bond between carbon and sulfur undergo breakage. The reaction goes to the formation of six-member cyclic transition state, and there is formation of olefin. Along with this one, there is a formation of byproduct SHC double bond O SME. When it undergo further changes, there is a formation of thiomethanol MESH plus carbonyl sulfide C double bond S double bond O as a byproduct. But we are going to mostly focus on the olefin formation. Now look at the condition or stereoelectronic requirement for cis elimination in case of cyclohexane system. In cyclic system like cyclohexane system, the axial equatorial alignment plays important role. In cyclohexane ring, the pyrolytic elimination reaction proceeds best when atoms or groups to be eliminated are cis to each other. Now this is the stereoelectronic requirement of the pyrolytic elimination reaction. That is, we can say that pyrolytic elimination reaction preferentially involve cis substituent. Now this is the consider that opposite as that of the biomolecular or E2 elimination reaction. In case of E2 elimination reaction, the atoms or groups to be limited, they must be trans-diaxial to each other. But remember, in case of pyrolytic elimination, the atoms or groups to be limited, they must be cis to each other. That is, they having the axial and equatorial orientation in cyclohexyl system. That is, we can say that they must be cis substituent. Then only then pyrolytic elimination is possible. Now consider example cis-2-phenyl cyclohexyl xanthate. What is the product when they undergo the pyrolytic elimination? And in case of trans-2-phenyl cyclohexyl xanthate, what is the product? The pyrolysis of trans-2-phenyl cyclohexyl xanthate produces predominantly the conjugated olefin 1-phenyl cyclohexene, whereas the corresponding cis isomer produces almost entirely the unconjugated isomer 3-phenyl cyclohexene. Now look at this one. If you consider trans isomer, when they undergo the pyrolytic elimination, two products are possible. First one is the 1-phenyl cyclohexene, which is the conjugated one, and the second one is the 3-phenyl cyclohexene, which is unconjugated one. Two products are possible. In case of, if you consider how these two products are possible, when trans isomer, if you draw its chair conformation, in which get the phenyl group is alpha oriented and the OCS SME group is beta oriented. That's why in chain form the alpha oriented phenyl having the equatorial orientation and that of that leaving group having the also having the equatorial orientation. That's why it is trans one. If you consider the elimination reaction, let's say whether it satisfies our stereoelectronic requirement or not. In case of cis-elimination, you have to follow the condition that the atoms or group eliminated, they must be cis to each other. In this case, with respect to equatorial leaving group, the axial hydrogen at the adjacent carbon having the cis orientation. That's why which undergo the elimination with respect to leaving group, and there is a formation of conjugated 1-phenyl cyclohexene. And in case of second one, if you consider the Hb hydrogen, which is also having the cis orientation with respect to leaving group, that's why that also involved in cis elimination, and there's a formation of 3-phenyl cyclohexane. In case of trans isomer equator-equator conformer, there is two possible cis hydrogen present with respect to the xanthate group, that is Ha hydrogen and Hb hydrogen, and hence elimination could take part with either hydrogen to give rise to two different products. As we have seen in the previous slide, two products are possible, 1-phenyl cyclohexene and 3-phenyl cyclohexene. Now question is that which is the major one, whether 1-phenyl cyclohexene or 3-phenyl cyclohexene. Okay, that we are going to see in subsequent slide. Now in case of cis hydrogen, if you draw a chair conformation, in that case cis phenyl xanthate 1 having only one cis hydrogen with respect to that axial leaving group. That's why in this case there is only one product is possible, that is 3-phenyl cyclohexene. But in case of trans, two products are possible. Whereas in cis isomer there is only one cis hydrogen with respect to the xanthate group, and hence only one product we got by elimination. Formation of the more stable conjugated olefin in cis isomer would involve an unfavorable trans elimination of the xanthate group and the adjacent tertiary hydrogen. Thank you.